and welcome to the network. Our objectives in this demonstration are really simple. It's to understand what is an Anycast address. That's number one. Secondly, identify why we would ever use one. And then third, identify how to configure it and verify that it is working. So let's jump right in. I've got an IPv6 network in place. I've got three routers. There's R1, R2, and R3. They're all connected to a network with various number of routers and such inside with their FA1/0 interfaces. Now let's focus on what an Anycast address is. An Anycast address is an IPv6 address that you're going to use more than once. But wait, Keith, I thought they all had to be unique. And that's the exception for Anycast. Anycast is an IPv6 address that you're going to use more than once. Here's an example. Let's say we hand out to customers, either through the auto configuration with the options set, or we manually configure our clients to use a DNS server of 2345::9. That's the IPv6 address of the DNS server. Well, once we hand out that information out to the clients, check this out. It would be nice if that server existed for them to do DNS requests with. So we can get a server on the network and give it that IPv6 address. 2345::9, and you can assign that, whether it's Linux or some kind of Unix or Windows or whatever. You could assign that IPv6 address to that box and have that box running DNS. The second thing we could do is take a second server, see down here I have DNS server number 3, and give it the same exact IPv6 hard-coded address. Now we've got Anycast. Poof, that's it. Well, Keith, okay. I understand you're saying that you're going to use the same IPv6 address on 2 or more boxes. But what's going to happen when a client, let's say a client is connected to R1, and it does a DNS request to 2345::9, which way is R1 going to forward to get to that server? Is it going to go north or south? And the answer is it's not going to go anywhere until we advertise the network of 2345 something into our routing protocol. See, just by putting the IPv6 address on 2 different devices isn't quite enough. We're also going to have to advertise that network, and that's where our routers come into play. So because we have this server up here at 2345::9, on this network, whatever it is, in this case it's the 2001-22 subnet or 22 network, we're going to add a second address to the router's interface for the benefit of advertising the 2345 network into the routing protocol. So this interface here is going to have 2 global addresses, one for the network address we want to use for our normal activity, and another Anycast address that we're going to use for the benefit of getting this network 2345 into our routing domain. The same thing down here. We have a normal network of 2001.33, could be any IPv6 network that we have connected, and we're adding a second 2345::64 with the keyword Anycast. Now, honestly, we don't have to put the keyword Anycast in, but when we do use the keyword Anycast, it also turns off duplicate address detection. So if we had 3 or 4 or 5 different routers all with that Anycast address, they wouldn't basically talk to each other and say, oh, that address is already in use, I can't use it, if we had multiple devices on the same network segment that we're trying to use it. So that's what Anycast is all about. So check this out. From a routing perspective, R1 is going to forward a packet to 2345::9 based on its routing table, and this cloud, and however many routers are in that cloud, it could be the whole world with BGP, or it could be as small as your corporate network, we are going to forward packets to the IPv6 address of 2345::9 that we feel is the closest. So if we're using RIP, which I hope you're not, it would be based on the number of hops, hop count. With OSPF, it would be cost. With BGP, it very might likely be the number of autonomous systems that we have to go through to reach that given destination. So it's all based on routing, which one we go to. And the other cool thing is that a client located on this network, it might go to, for example, this DNS server, while a customer who's located off of R2, or off of R3 rather, is very likely to go to this DNS server because from R3's perspective, this is the closest destination. So we have fault tolerance. If either one of these goes belly up, we still have that IP address being supported because it's an Anycast address. So that's the what is an Anycast address. It's an IP address that's used more than twice or 2 times or more. And we also talked about why. It's for fault tolerance. So you can have 2 or more devices supporting the same service. So if these 2 really are DNS servers, we're good to go. Now the last piece is how. How do we configure this? And what I've done is I've taken R2 and I've totally wiped out its interface FA11 interface. So you could go ahead and see the results of us putting all the config in. And also R3's FA11 is completely wiped out as well. We're simply going to put in 2 IPv6 addresses, one for the normal unicast and one for the Anycast. And then we're going to add a routing protocol to it as well. So let's start up here on R2. In fact, you know what? Let's do one other thing. Before I start adding any new configuration to R2, let's turn on debugging on R1. Why? Because I want you to see the results of what's really happening behind the scenes. So on R1, let's just go and do a debug of IPv6 routing. If I could just spell it. There we go. So debug IPv6 routing will show us any changes to the routing table, and we'll do a show IPv6 route for OSPF. So right now, R1 has some routes, and it's these 3 networks that it knows about at the moment. So let's run up over here to R2 and configure this interface FA11. We'll start by getting on the right device. That's a huge leap in the right direction. And on R2, we'll simply go into configuration mode for, again, this interface, FA1/1, and we'll specify that we want to use the unicast address of 2001:22:2/64, which will start the whole features of router advertisements because IPv6 unicast routing is enabled. And I've also put this interface into OSPF. Now, the second piece is because OSPF is running on this interface, by adding a second IPv6 address of 2345::/64. I don't need a host ID. I'm going to use the keyword Anycast so it doesn't do duplicate address detection. Not that it's needed, because in this environment it's not going to find another address just like that. And I'm done. Now what just happened is because I just put this network and this network on this interface and I put them both in OSPF, R1 now knows about those 2 networks. Let's go take a look. So over at R1, he had some interesting things happen. He says, oh, I'm adding the network 2345 and I'm adding the network 2001:22. So he's added both of those networks to his routing table. So we did a show IPv6 route OSPF. There's the 2 new networks. We have the 22, which is up here on top, and we have the 2345, which is right here. Great. So now we've got those 2 routes. I'm going to leave debug IP routing on R1, and let's go down and configure R3 with almost identical information. Now, when I say almost identical, we're going to put a different network address for unicast, and we're going to put also R3's FA11 in a different OSPF area. But besides that, the Anycast portion will be identical. So into interface FA11 we go. We're going to apply the unicast address of 2001:33:3 with a 64-bit mask. And then we'll add that to OSPF. So now it's in OSPF. It's going to be in area 3. And just like before, if we want to advertise the 2345 network from R3, we'd simply add that 2345 address to the interface, and poof, that 2345 network is also going to be advertised into OSPF. And then it's up to OSPF to decide which of the 2345 networks from R1's perspective is the one we're going to forward to. So we're done. Now, if we hop over here to R1 and take a look at the output, you'll notice that we have the new network of 2001:33. Fantastic. And we've also got this new route of 2345 that's also been added. And I'm going to scroll over just a little bit so you can see this. Check this out. It said that we are going to add the route 2345 with a better metric of 53. The old metric had been 68. So the cool thing here is that it's added. It has a better metric of 53, and the old metric was 68. So it basically replaced that route. If we do a show IPv6 route again for OSPF, you'll notice that it now has the route with a metric of 53, when previously, right here at the top, it used to have a metric of 68. So now it's actually routing to a different one. In fact, we know because we added R3 later that it must be through R3 that has the better metric through this network. So how would we verify that? We could also trace to verify. Let's just do that. Let's do a trace route to 2345 colon 9. And that's going to show us that we're going right through the 33 network. And that is through R3 to get to that destination. So that's our path as we go through the network, is going south. Now, what would happen if we change this? Now, if we change this, like for example, if R3, if we shut off this interface to demonstrate the fault tolerance, let's go ahead and do that in the configuration mode, interface FA1/1, and we'll simply say shut down. Now, that's pretty rude, but this simulates a failure of that portion of the network. Customers who are still trying to get to the DNS server at 2345 colon 9 will still be able to do so because that network is still being advertised and there's still a server hanging out there. So there's our debug of IPv6 routing. We'll do a ping again. Let's do a trace to 2345 colon 9. And now it's going up through the 22 network, which is right here, to get to that resource. So that's a demonstration of actually applying it. And it's really, really simple. If we do a show, let's do a show run of interface FA1/1. And here's our config. We have our unicast address and our Anycast address, and we've advertised both of those into OSPF. The reality is, if we had put 2345 colon 1/64 and not use the keyword Anycast, it would still work identically. The Anycast keyword, the biggest part of that is simply to mitigate the duplicate address detection. So any way you want to slice this, you can. The key is put the networks into OSPF or into your routing protocol, and then configure your servers hanging off of those networks with the exact same IPv6 address. And as a result, you'll have fault tolerance with IPv6 and Anycast. Hey, thanks everybody. It's been a blast. Catch you in the next video. Bye-bye.